Hello everyone. I hope you all are fit and fine. So let's make something new today. We are going to make a mini electronic circuit project, a constant and variable DC power supply. That means we make a circuit which give us an output of a constant voltage 5 volt or 7 volt or 12 volt. Accordingly to we set the particular component value. We make this project in a 3 phase. In a first phase, we can learn about the concept. In the first phase, we discuss the objective of our project, concept of our project, and the circuit and the working of the circuit. In the second phase, we make a circuit layout using a Express PCB software. If you want to make this project and you don't have this software on your PC, then the link of the software in the description box. You easily download it and it is a open software. So you use it without any cost. In the third phase, we will check out our circuit working by using the breadboard. After that, we make our PCB tracks and drill the component on it. It is very important to know that we make a circuit in a two-way. First, by using a copper layer, and second, by using a 1.6 mm thick strip board. Usually we call it a Vero board. So we use here a Vero board because it's required no specific chemical processing. The components are connected via a copper tracks laid down in strip on a 0.1 inch grid of a pinhole in an insulating board. So let's make it. First phase, objective of our project. Our objective is to design the circuit for variable or constant DC supply that varies 2 volt to 12 volt using a LM317 regulator. And the second objective of our project is to observe the output to meet the requirement. Now we discuss the block diagram of our circuit. Here we make a variable DC power supply. The main working principle of the project is full wave rectification, which is done by the bridge configuration, where we are using a 4 diode and those rectifies the output of the step down transformer that step down the 220 AC to 6 volt fluctuated DC. For smoothing the output of a bridge rectifier, we are connected a capacitor or a resistor by charging and discharging, and it is used to get a constant input to the regulator also. Moreover, it is also help to reduce the sharp peak in the output. We use also a regulator for regulate the final output by adjusting the potentiometer and adjust the output voltage 2 volt to 12 volt as per our requirement. So how circuit work? The working of the circuit is so simple. When we apply 220 volt and 50 hertz supply to our step down transformer, the transformer can convert it to the 6 volt fluctuated DC. After this fluctuated DC is passed by the bridge rectifier. After a first positive half wave of our first input cycle, again I say, after a first positive, I means that during the first positive half wave of our first input cycle, We know that the terminal A become a positive and terminal B become a negative. This results in a diode D1 and D3 become a forward bias, and the D4 and D2 becoming a reverse bias. First, negative half wave of the cycle in the terminal B, it becomes a positive and makes terminal A becomes a negative. This causes a diode D2 and D4 becoming a forward bias and diode D1 and D3 to becoming a reverse bias. So the output of waveform of the bridge rectifier are like this. After that, look at the capacitor. The positive pulse at the input causes the capacitor to charge through the diode D1 and D3. And after the negative half pulse arrive at the input, the charging action of the capacitor is decreases and it start to discharge via a resistor. This results in a generation of the DC output which ripple it as shown in the figure. We can minimize this ripple by using regulator IC317. So IC317 is a adjustable 3-terminal positive voltage regulator and it is capable and output voltage range from 1.25 volt to 37 volt. We can adjust the RF, means the adjustable port, via a potentiometer and change our output voltage accordingly to our requirement. Component of the circuit. Here we use 1N4007 rectifier diode. It is designed specifically for a circuit that need to convert a alternating current to a direct current for AC to DC. It passed the current up to a 1 ampere. So it is safe for us. The second component is transformer. We know that transformer is a equipment that used either for a rising or lowering the voltage of an AC supply with corresponding decreasing and increasing current. Here we use a step down transformer that can step down the voltage from 220 volt to 6 volt. Third component is a capacitor. Here we use two different value and the two different type of capacitor. Electrolyte capacitor for a 10 microfarad and parasitic capacitor is for 0.01 microfarad. Fourth component is resistor. Here we use a resistor of a value of 1 kilo ohm. We also use a potentiometer here of a 10 kilo ohm. We use this potentiometer for adjusting the terminal of IC317. After that, we use a LED, green LED as well as we use a red LED. After that, the main component is our circuit LM317 IC. We use IC 7805 or 7812 instead of LM317 by constant fixed voltage of 5 volt or 12 volt respectively. But here we make a circuit that we change the voltage accordingly to our use. That's why here we use LM317. Otherwise, we use 7805 for 5 volt and IC 7812 for 12 volt. Phase 2. Layout design. Now we make a PCB layout design of our circuit. The engineer at a Express PCB have assembled a few general rules for a thumb that can help the beginner designer for the circuit board. So first we placing a component. Generally it is a base to place a part only on the top side of the board. When placing the component, make sure that the snap to grid is turned on. Usually a value of 0.050 inches snap grid is best for this job. First, place all the components that need to be specific location from the component library. These include a connectors, resistor, capacitor, LED, our IC or any other item that mount on the external location. Give careful through when placing a component to minimize a track length. put a part next to each other that connect to each other. Now, before the fabrication the component on the Vero board and soldering, we first check the working of the circuit by using the breadboard. Put all the component in the breadboard as per our circuit and check out the working of the circuit. After that, we will compact the component as per our layout in the Vero board. So to fabricate the component inside the Vero board, we will copy of the layout, or we can draw the copy of the layout on the board. It is easy to identify the component, and it is a positive and negative side. We also know that after watching that layout. So it is easy to insert a component on the Vero board. After inserted the component in the hole, it's time to soldering the circuit and join the tracks as per our layout. Here we can see that if we increase and decrease the potentiometer, the reading of our output voltage inside the multimeter is increasing. By adjust the potentiometer at a 6 kilo ohm, we get approximately 5.75 volts. So it is identified that our circuit is working properly. Now use. Now our circuit are ready to perform a task like a power LED, charge a rechargeable cell and so on.